This presentation is on Center for Advanced Studies Innovation Impact, which is intended to be consumed by WebSphere Integration Developer product, and in more particular, the XML schema mapping tool of this product. The primary academic researchers for this project were Professor Dr. Mariana Consens of University of Toronto and his PhD student Shahan Khachadurian. Our academic partners noticed that there are quite a lot of types of XML datasets which are very hard to describe and to visualize. For example, let's consider XML dataset that corresponds to an XML schema which is very large, and only a small part of this XML schema is used for any specific XML dataset. That means that such XML schema does not provide a very intuitive description for an XML dataset at hand. Another example is when XML schema is very lax and optional appears everywhere. Again, although this schema exists to describe certain XML dataset, it's not very intuitive in description of the particular instances of the XML. Yet another example is when schemas have a lot of any elements and therefore composed very unpredictably. Yet again, that doesn't provide a good description for a specific XML dataset. And finally, what to do with XML datasets which might not even have schemas or DTDs to describe them, so-called semi-structural XML datasets. The theory that researchers had is that XML structural summaries, meaning graphs that represent relationships between sets and specific XML datasets, can be actually somehow used to describe the structures for these particular situations. This hypothesis led to an extremely well-received research, which resulted in an invention of the DescribeX framework. DescribeX is a framework for specifying access path regular expression summaries, meaning the specific summaries which can be identified in existing XML datasets. The DescribeX extends and unifies a lot of previous approaches to summarizing XML collections, and also it expresses all the bisimilarity structural summaries. DescribeX was also implemented as an Eclipse-based tool for exploring and visualizing XML document collections. So the research was done, and the most natural question that arose right away was, how can we harvest this great research that was done and to consume it as part of the IBM product offering? One of the primary targets for research consumptions that we have in mind is WebSphere Integration Developer product. Partly because WebSphere Integration Developer customers very often work with large industry schemas, and those schemas quite often have any elements, optional elements, and by itself often are very, very large. So Dave Spriet, who is an IBM technical lead for XML schema mapping editor of WebSphere Integration Developer, gave us an idea to see how this research result can be used to visualize XML schema elements within the editor that need to be mapped based on some sample XML collections of the datasets that customers use in their shops. Let's see how it all can work. For example, customers need to map two schemas to each other. And let's assume that those schemas are really, really large, which is exactly the case for many industrial schemas. There is a high chance that the XML elements and XML collections which customers use as part of their work utilize only fairly small fraction of those very large and very extensible industry schemas. So for the customer to actually know what elements need to be mapped within the XSD mapping editor, The customers have to sift through execution logs, look at the documentations, maybe even look at all the XML instances that they have to identify the elements which are relevant and need to be mapped to each other. However, with the use of the research results for this project, we can use summaries in the XML datasets on input and on output of the mapping to actually identify what are the schema elements that need to be mapped. Meaning, what are the schema elements that correspond to the XML elements on source and target XML datasets. It should be noted that we are not deducing any mapping rules that customers might have in their minds. The only thing that we do here is just give customers visual cues of what XSD elements correspond to the XML elements used in their sample XML collections. So customers can very easily draw their mapping relationships between schema on the source and schema on the target. Certainly, there is much more harvesting opportunity for this research to be consumed as part of IBM products than just XSD mapping editor in WebSphere Integration Developer. Multiple products and brands in IBM are using XMLs, XML schemas, and XML collections. And very often, just by nature of industrial focus of IBM software, those XML collections and XML schemas are very large and very extensible. So some real customer pains still need to be addressed, and the research results of this project can really be used to address those customer pain points and deliver the value to IBM products. However, let's just look at what kind of product impact and what kind of customer benefit can be derived from this research consumption by WebSphere Integration Developer when such research is adopted by the product. First of all, product impact results in much improved mapping problem determination tools by providing visual indications for XML schema mapping tool. That naturally improves the support for handling the industrial schemas, and that's exactly what customers are currently asking from IBM. And why customers need that? Well, XML schema models used by the industries are very large, very sparse, have lots of optional elements, and designed to be extensible. But what it means is that XML datasets used by any particular customer very often uses only a tiny portion of the industry schema. Therefore, providing customers with more visualization and more cues on what elements to map actually significantly improves customer productivity and user experience. In terms of the business impact and results of this research harvesting project, what we are hoping for is an adoption of this proof of architecture and proof of concept by WebSphere Integration Developer in the future releases. And thereby, we're hoping to improve IBM customer productivity and the user experience with WebSphere Integration Developer.